So let's start off by looking at this question about blocks. So how many different ways can you arrange two blocks? Well, this is a pretty easy question, but it's going to build up to some more difficult ones. So there's two ways that you can arrange two blocks. That's a pretty obvious answer. You could have the red one first and then the blue one, or you could have the blue one first and then the red one. That's it. Two ways. Because after you pick that first block, well, there's only one block left, so there's only one way that you can put it on there once you've chosen the first block. What about when you have three blocks? How many different ways can you arrange them? Well, if you choose the red block first, you have two ways that you can arrange the remaining two blocks. So if I had the red one first, I could do blue and then yellow, orange, whatever color that is, or I could do it the other way, orange and then blue. So there's two ways that I can arrange the remaining two blocks after I've chosen the first block as red. Well, I could also choose the first block to be blue. Well, after I've chosen the first block to be blue, I could choose red and then yellow, or I could choose yellow and then red. So once I've picked that first block, I have two ways to arrange the remaining blocks. And the same thing is true with yellow. After I pick yellow, I have two ways that I could arrange the remaining blocks. Okay, so this may seem pretty easy so far. Let's put this that way. And there are 6 ways that I could do it total. These represent all the arrangements of 3 blocks. 2 ways I could choose for red, 2 ways I could arrange them if I chose blue first, and 2 ways I could arrange them if I chose yellow first. So after I pick that first block, there's 2 ways to arrange each of them, and there are 3 ways to pick the first block, and then 2 ways to arrange the remaining 2, so there are 6 ways total. Well, what about 4? The idea extends. So if I picked the first block as red, and then I did all the different arrangements of that, there would be 6 of them. So after you pick red as the first block, there are 6 ways to arrange the remaining 3 blocks. And it's the exact same 6 ways as you would see here. After you pick that first block, there are 6 ways to arrange it. 2 for each of the remaining colors. Well, I have 4 blocks that I could pick from to start off with. I could pick red, or I could pick blue as the first one, or yellow, or green, and for each one, the remaining 3 blocks, there are 6 ways that I could arrange it. So I had 4 ways to pick the first block, then there were 6 ways that I could arrange the remaining 3. 6 ways to arrange the remaining 3. Well, interestingly enough, that's the same thing as 3 times 2. So to arrange 4 blocks, there's 4 times 3 times 2 ways that you can arrange 4 blocks. To arrange 3 blocks, there were 3 times 2. And that pattern continues. So if I was going to arrange 5 blocks, it would be 5 times 4 times 3 times 2. That would be the number of ways I could arrange a block. Because as you add a new option, well, these are all the options for 4, but then if I put a 5 there, I would have to redo all of these options for each of the 5 colors. So that would be 5 times this many, which would be 120 if it was 5 blocks. How many different ways can you arrange one block? Again, an easy question. There's only one way. I can put it here, and then I could put, well, that's it. There's one way to arrange one block. How many different ways can you arrange 0 blocks? This may seem like kind of a useless question, and you might automatically think, well, there's no ways you can arrange 0 blocks, but that's not actually true. There's one way. One, and I've done it. You're looking at it. This is the only way that you can arrange 0 blocks. You can't. That's it. Okay, why am I telling you there's no ways you can arrange 0 blocks? This is why. Because we're talking about the concept of factorial here. What factorial means is you take some number and you multiply it times every number smaller than itself until you get to 1. But what about when you have 0? Well, you can't go 0 times whatever. 0 is kind of a special case. You get 1, and you need that to be true when you do combinations later, because if I said for example, if I said you had 4 blocks, how many different ways could you pick no blocks? Well, there's one way you can pick no blocks. You're choosing not to pick any blocks. And we need that idea to be consistent. If you don't like that explanation, just kind of accept this as a part of the definition of factorial when we use it later. Okay, 4 students run a race. How many different ways can they get first and second? So this is similar to the 4 block question that I asked you earlier, but now it's only 2 places. It's not how many different ways can you arrange all of them. It's how many different ways can they get first and second. Well, let's look at it real quick. Red could get first and blue could get second, or red could get first and yellow could get second, or red could get first and green could get second. Those are the only ways that red could get first. Okay, these are all the possible combinations. So if blue got first, blue could get first and then red could get second, or blue could get first and yellow could get second, or blue could get first and green could get second. These aren't great student names, but red, blue, green, it is what it is. All right, and the same thing continues. Okay, if yellow was first, there are 3 ways you can do that also. And then the last one, if you notice, there's 3 ways you can do it for each one. So 3 times 3, or 3 plus 3 plus 3, and then the last set of options that you have over here gives you 12 total. Well, how can we do this without dragging blocks all over the screen? Okay, well, there are 3 groups here. So there's 3 rows, and then there's 1, 2, 3, 4 columns. So it's 4 times 3, which equals 12 different ways that you can do this. Here's a formula. Permutations. The number that you have, and then you want to figure out how many different ways can you arrange them into 2. Well, what you're asking is, you have this place, you have first place. How many different people could I choose for first place? Well, I could choose 4 because I have 4 people. But then second place, how many different ways could I choose a person for second place? I can't put 4 anymore because I've already chosen a person. Whoever I chose here isn't an option anymore. So there's only 3 there, which equals 12. And this is what this formula will simplify to. If n is 4 and r is 2, you have 4 factorial over 4 minus 2 factorial, which is equal to 4 factorial over 2 factorial. And let's simplify this. 4 factorial means 4 times 3 times 2 times 1. 2 factorial means 2 times 1. You can cancel out those last 2 factors and you're just left with 4 times 3, which is 12, as we've seen before. Let me take a second here to mention that writing out all the factors isn't the best way that you could do this. I could have written 4 times 3 times 2 factorial, and that's the same thing as I have on the numerator over here, over 2 factorial, and these cancel out. It may seem kind of arbitrary because I'm not writing times 1, but here's a better example. Let's say you had 250 people and you wanted to pick just first and second out of those 250 people. Well, you would write 250 factorial over 250 minus 2 factorial. That's 250 factorial over 248 factorial. If I was going to write this out, 250 times 249, and I just kept going down to 1, that would take an extremely long amount of time. But if I wrote it like this, times 248 factorial, that means the same thing as 250 factorial over 248 factorial. Well, then these cancel out, and I just have 250 times 249, so that makes my life a little bit easier. So canceling out with the factorial notation is a good habit to have. All right, so now let's move on to a different type of problem. You have 5 students running a race, and the top 2 students are going to advance to the next round. This is kind of like the Olympics. You have the Olympic heats where they run, and the top 3 places get to move on to the next heat, and then they all run again. And then when you actually have the Olympic final race, then first and second place matters, but before that, all that matters is you made it in the top 3 so that you could move on. Okay, so how many different ways can you choose 2 students who advance out of 5? This is just choosing 2 students where the order doesn't matter. So let's say red gets first and blue gets second, or blue gets first and red gets second. These 2 cases we don't want to count as separate because they don't matter. It means red and blue both advanced. So we're going to have too many cases by exactly 2 times as much. Every single time you're going to have like yellow, green, green, yellow. It's the same thing as red, blue, blue, red. Each one's going to show up twice, but we really only want to count it once because we're counting the people that advance. So we need to add something to our formula. So we've added something. We had NPR is equal to n factorial over n minus r factorial. And this is the exact same thing as a combination, except for this term right here, r factorial. Well, if we think about it in the case that we have here, we have 5, and we need to choose 2. Well, that's 5 factorial over 2 factorial times 5 minus 2 factorial. So what we have is this extra 2 on the bottom, and if we remember what I said on this slide, we're going to have exactly 2, the things are going to show up twice, okay, because that's how many ways you can arrange the first 2 places. And so we need to divide by 2 at the end in order to get really the number of ways that you can send 2 students on out of 5. So let's simplify this formula, 5 factorial over 2 factorial, 3 factorial. And it's always going to be like this. You'll have 2 plus 3 equals 5. So this is 5 times 4 times 3 factorial over 2 factorial, 3 factorial. These are going to cancel out, and you have 5 times 4 over 2 factorial, which is the same thing as 5 times 4 over 2, or 10. Okay, now I'm going to do something. So there's 10 ways that you can pick people to move on. So I'm going to actually go back and I'm going to show you all 10 of those ways. If I was going to do all the possible combinations with red, it could be red and blue, or I could have red and yellow, or I could have red and green, or I could have red and yellow. Oh, so I guess this is red and orange. Okay, so that's all the different ways I could have 2 people advance, where red is one of them. Now let's do it with blue. Well, I could have blue and red. Oh wait, I already counted that group, so I'm not going to count that this time. I could have blue and orange, or I could have blue and green, or I could have blue and yellow. And that's it. Okay, now let's do orange. I could have orange and red, but I've already counted that, or orange and blue. Well, I already have that group, so it's orange and green, or orange and yellow. And those are the only ways that I could do that. Well, now let's do green. Well, I could have green in any of these, but those are already accounted for. I have green and green and orange, I have green and blue, and I have green and red. So now green and yellow is the only option that's left. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I was to fill in the other part of this triangle, if you think about a triangle kind of like this, okay, I guess it would be a rectangle. All of these would repeat themselves, but just with the order switched, and then that would be 20. That would be what it would be if the order mattered. So I needed to divide by 2, and that's exactly what my formula did. It divided by 2. Okay, but what if I was saying there were 3 people that it could advance? 5 choose 3. Okay, well that would be 5 factorial over 3 factorial times 2 factorial. This is going to be the same number, 10. So I'm going to show you with 10 also. Okay, so how many different groups of 3 could go with red? It could be red, blue, and orange, or it could be red, orange, and green, or it could be red and blue and green, or it could be red and blue and yellow, or I could have red and orange and yellow. Okay, I think that's all the possibilities with red. So red, blue, there's 3 of those, and then red and orange, there should be 3 of those, 2, 3. Red and green, 1, 2 of those. Okay, so red, green, and yellow. Red, green, and yellow. And then let's see, red and yellow, there's 3 of those now also. Okay, so that's all the different ways that I could choose a group of 3 that has red in it. 1, 2, 3, 4, 5, 6. I've got 6 of those, okay? And there's only 10 total, which is kind of surprising. Okay, let's do all the ones you could do with blue. Blue, red, and orange. I already have that one. Blue and... So now it has to be a group with blue that doesn't include red. So that's blue and orange. And now I can say blue and orange and yellow. Now that's all the blue and orange that I can do. Now let's do blue and green and yellow. And I could do blue and green and orange, but I already have that one. Okay, so now let's go down to the orange ones. I could do orange, and I can't have red or blue in it because I already have those groups. So orange and green and yellow is a possibility, or I could do orange and yellow and green, but that's already it. And so here we have all of the possibilities. You have 6 ways you can do it with red, but then 3 of them were eliminated, and then 2 were eliminated, so we have 10 total ways that we can do it again. Okay, so let's try and think about why is this happening. Okay, so let's look at our formula. We have 5 factorial over 3 factorial times 2 factorial. What we're doing in this case is we're doing 5 times 4 times 3 times 2 factorial over 3 factorial times 2 factorial. These are canceling out, and we have 5 times 4 times 3. This is what it would be if it was permutations, right? We have 3 spots. If we were looking for first, second, and third, we would say 5 times 4 times 3. But that would be too many. It would be too many by exactly a factor of 6. 3 factorial, which is 6. 5 times 4 times 3 over 3 times 2. The reason why you divide by 6 is because that's how many times this would repeat itself. 6 times these things would repeat themselves. Because I could take this one and I could say, I could rearrange it into this order. And I could do that, and I would have 6 different arrangements of these 3 colors. But I don't care about the 6 different arrangements of these 3 colors that I can have. All I care is that those 3 colors are in a group together, and they went on. So that's why there are 6 times fewer. So divided by 6 from the total, and you get 10. So the takeaway from this is you have permutations and you have combinations. If the order matters, then you use the permutations formula, which is here. And if the order doesn't matter, you use the combinations formula, which is here. You should have fewer combinations than permutations. That's it for this lesson.